What is up, YouTube? Welcome back to another episode on Code with Annie. And in this particular episode, we're going to take a look at the new sorting technique called as the QuickSort algorithm. So we are continuing the sorting series, and it's not per se a sorting series, but we have started looking at all the sorting algorithms. As you can see, we started off with bubble sort, this is insertion sort, then we had selection sort, and now we are going to take a look at one more sorting technique, which is QuickSort. Now, QuickSort is quite popular for two main reasons, because one is it is said to be the industry sorting technique, meaning many of your interview questions mostly will ask you around QuickSort because it's slightly faster depending upon where you choose your pivot element, because it is focused on a pivot based sorting. It is also an in place sorting technique, meaning you don't have to create a separate array, or you don't have to create another data structure to save the sorting results. It's going to be in the same array, so it is in place, but it takes O of n log n time to complete based upon your pivot position. Okay, so let me explain you this sorting technique quickly in this video, and without further ado, let's get started. QuickSort can be explained with a simple example. Let me take an array first. Let's take some elements in the array, 14 and 5. Okay, now we have an array of 5 elements, and I want to sort it in, as I guessed, right, the ascending order. That means 1 will come first, followed by 5, then 12, 14, and finally 60. Now, how QuickSort works is it makes use of 3 pointer positions. Okay, one is called as the pivot. Okay, and the pivot can be chosen to be any element in this particular array, but mostly it is chosen either as the first element or the last element or the median element, which is basically 60 in this case. Now let's take an example of choosing the first element as pivot. So my pivot is going to be 12, okay, at position 0. Okay, this is the 0th position of the array. And then we have the left pointer, which points to the leftmost element in the array, which is 12, position 0, right? And then you have the right pointer, which points to the rightmost element in the array, which is 5, and the position for that one is 4, because the array's length is 5, so it starts off with 0, and this is going to be position 4. Now, once we have this in place, what we'll do is we'll start this sorting technique from the right side. The reason is your pivot and left are pointing to the same element, right? When you have this kind of an arrangement, then you start from the right. But if your pivot and right are pointing to the same element, then you start from the left. Okay, keep this in mind. So our starting position for pivot and left is both pointing to the same element on the left side. So therefore we start picking up the elements from the rightmost position of the array. So we'll pick up 5, we'll compare it with 12. The idea is the element that we pick as pivot, when we are done with this sorting, will have all the elements to the left of the pivot less than the pivot element, and to the right of the pivot as greater than the pivot element. What I mean to say is, when I'm done with this sorting using pivot, when I have 12, let's say in the position of 60, then everything to the left of 12 will be less than 12, and everything to the right of 12 will be greater than 12. Okay, so I start off by picking up the element 5, and I compare it with 12, and I see that 5 is less than 12. Therefore, I do a swap between 5 and 12. So 5 is less than 12, therefore swap positions of 5 and 12. Okay, so what will happen is 5 will go to this one and 12 will come here. So the new array will look like 5, 1, 60, 14 and 12. Okay, now your left pointer is still pointing here. So left is pointing to the element 5 right now, because left is pointing to the first element in the array, right? So your left is pointing to 5, position 0, and the right is pointing to element 12, because 12 has now switched, it's come to the right position, right? So 12 and position 4, and pivot is still 12 and the position is 4. Pivot will not change until the entire iteration is complete. So pivot is now sitting here. All right, now you see that pivot and right are on the same place, therefore we start picking the elements from the left side. So we see that 5 is already less than 12, so because we just swapped it, so we'll leave it. Then we'll go to the next one. Left will now point to element 1, position 1, and 1 is less than 12, right? So we'll still continue. left will now point to position 2, which is element 60 position 2, and 60 is greater than 12. So again we see that something greater than 12 is lying on the left side of 12. We'll just simply do a swap. As I mentioned, when you're done with this kind of a swapping using pivot 12, all the elements less than 12 will be on the left side of 12, and all the elements greater than 12 will be on the right side of 12. So we're going to swap 60 with the pivot position 12. So once you're done here, the array will look like 5, 1, 12, 14 and 60, right? And if you observe, we kept moving the left element. The last position of left was position 1, or was it position 1? I think it was position 2, right? Yeah. Last known position of left pointer is position 2, which is now pointing to the element 12 here. So left is now pointing to element 12 and position 2. Pivot is still element 12 and that is also at position 2, and right is pointing to the element 60 at position 4. Alright, so now you see that left and pivot are in the same place, so we again start picking the element on the right side of the array. So we'll start picking up 60. We see that 60 is greater than 12 and is also lying on the right side. We don't do anything to it. We come to the next element, which is 14, and 14 is also greater than 12. So I mean, right pointer is moved again to position 14, and that position is 3. 14 lies in the array position 3, and 14 is also greater than 12, so we leave it as it is. And end of the day, when you reach a point like this where left is pointing to these two elements and right is also now moved to position 12, position 2, you see that left, right and pivot all point to the same position in the array, same element. That's it. We have reached the end of the iteration. This is going to be your exit condition for one pass of QuickSort. So this is the first pass of QuickSort. So end of this, we just return the array of whatever position it is in. This is the state of the array at the end of the first pass in QuickSort. As you can see, 12 sits in the middle, and elements to the left of 12 are less than 12. Elements to the right of 12 are greater than 12, right? Now, what happens in the QuickSort algorithm is that the elements on the left side, right, this portion is sorted separately, this portion is sorted separately, and both of them are again sorted through same QuickSort technique. So what we do is we simply pass the element 1, 5, and we decide one of the elements as pivot. Again, we can take 5 as the pivot between 1 and 5, and then we can compare and we'll swap. Same case with 14 and 60, and 14 can be taken as pivot, and 14 and 60 is compared and swapped. And then once everything is done, the subarrays are all sorted, the total array will be completely sorted, and this will be the result of the sorting technique. So 1, 5, 12, 14 and 60. This is going to be the end result. So QuickSort is recursively applied on the subarrays. So for example, if you initially call QuickSort with let's say value starting position 0, okay, and ending position is 4, for example, because that's the length of the array, okay, and the pivot element position is 2, right? So initially when we started off, let's say the pivot element position is also 0. We started off like this. Now what will happen is we'll call QuickSort again, but so let's say this is the start position, this is the pivot position, for example, or end position, start, end, and this is the pivot, okay. Now the next time we do a QuickSort between the subarrays, one subarray will be starting from the start position. I'll go till pivot minus 1 because we want to go, pivot is at position 2, we'll go till this part. So pivot minus 1, that is going to be the end, okay. And whatever is the pivot element that is to be chosen between these two. So ideally you don't pass this here, but the pivot position, once you calculate it, will be for the next subsequent QuickSort will be the position minus 1. So in case you started off with 12, whatever is the last position of the pivot minus 1, here it is sitting in the middle, so it's going to be till 1, 5, and again you will do a QuickSort, and this time you'll say you'll do a quick sorting from pivot +1 to end. So these are the two subsequent calls for the individual subarrays 1, 5 and 14, 60. And this will be the start, this will be the new end, and a pivot will be calculated for this one, a pivot will be calculated for this one. Usually if you think for the algorithm, the pivot is always going to be the first element of the array, then you can go ahead and do that implementation. You can pick up the last element as well, that is up to you. You can pick up any middle element as well, that is also up to you. And based on that implementation, the algorithm's complexity will usually change. In general, the average case complexity for QuickSort is considered to be O of n log n. That I will show you when we implement it in Java code. So that's it for this particular video. If you liked it, hit the like button, subscribe to CodeWithAni if you haven't already. It might be a little bit of a stretch for this video. I apologize for a delayed video. I'm having a lot of work that is happening in my office as well as at home. So that is why there has been a significant delay in the videos. But rest assured, the data structure series will continue. And I'll see you guys in the next one very quickly with the Java implementation for this QuickSort technique. Take care, guys. Bye-bye.